失礼しました。続いての発表は、一般発表30、オープンストリートマップとオーバーチュアマップスをはじめとする地図データセットを比較するツールの紹介という題目で、ロケーションマインド株式会社のマーゴリー様よりご発表いただきます。それではよろしくお願いします。よ
ろしくお願いします。今日そうですね、今日リリースしたオープンソースツールを紹介したいと思います。ジオデータコンペアという名前で、メインデベロッパーが隣にいるルイヤー・マティス。ちなみに僕たち2人はフランス人で、今日はフランス人が多いなと思った。ロケーションマインという会社は、東大発ベンチャーで2019年の終わりぐらいにできて、で今は70人ぐらいになっています。でそのプロジェクトは5人のプロジェクトで、そのロケーションマインドのほとんど初めてのオープンソースプロジェクトと言ってもいいです。でロケーションマインドの特徴は、日本だけじゃなく、世界中の、位置移動データを扱ってて、そうですね、グローバルという世界の社会問題を解決、できるように技術とソリューションを提供しています。頑張ってます。でなぜこのツールを作ったのは、ロケーションマインドは、その位置移動データを処理するときに、背景というかな、道路とか建物とか、が必要になってて、例えばマップマッチングとかするときに、なのでその背景データが必要になります。もちろんオープンストリートマップもあるんですけど、最近できたバーチュアルマップスもあってて、地域によってレイヤーによってそのデータセットがどんな程度にカバレッジがいいか、弱いかとか、そしてそのデータセットの、お互いの比較はどうなっているかを自動化して簡単に分かるように、ジオデータコンペアを開発しました。でこれからメインデベロッパーのマティスさんにマイクを渡します。すみません。お願いします。
Okay, sorry, I have to speak English because I can't speak Japanese, but the presentation will be in Japanese. So quickly, what is important about OpenStreetMap is that there is no forced schema for any themes and no quality assessment. And about Overture Map Foundation, as it was mentioned before, the transportation data is still not under global release. And as it's new, it's quite complicated to actually know what the data set looks like. So what we're going to present today is 3 demonstrations about buildings, roads, so transportation themes, and POI. And then we'll explain the workflow and the possible improvements. So GeoData Compare is a Python application that that is made with Shiny for Python and Longboard. That are 2 Python packages. And for the data assessment and quality assessment and data integration process, we used 2 Python packages, so GeoPanda and DuckDB. And the tool is available on under the MIT license at this address, LocationMind/GeoDataCompare on GitHub. So this is what the application looks like. So on the left side, you have the choice to select the area and the criterion you want to display, and also to customize the style of the layers. Then you have information here that are either static information about the area or information that depends on the criterion. And then you have the main maps and data frames that are going to display the information for the same area. So on the left, it's OpenStreetMap, and on the right, it's OvertureMap. And then you have different resources, such as help or information about the licenses. So the question is, how can one use geodata compare? And as I said, we'll present 3 demonstrations. The first one is about buildings. And let's say that you're like, for instance, public administration, and you want to do a study of land cover in Morioka, Japan. Then which data set should you use? So in order to compare 2 data sets, we have to choose criteria. So here the criteria are quite easy. It's the number of buildings and the density of buildings in the area. So this is the demonstration. So as I said, there are like so the different resources on the top page, and then we have the 3 different areas that we're going to talk about during this presentation, and the different criterion that are gathered in themes. So either a graph, building, or places, or POI. And then when we load the layers, all the components will be loaded at once, because it needs to gather the data and then display it. And so here we have the information about Morioka. We can change, for instance, the color of the buildings, and then we can, the area is not represented on the map, but you can easily guess where it is. And also, then we can actually compare the 2 data sets. So here on the left map, on OpenStreetMap, we don't really have that many buildings. But on OvertureMap, we do have a lot. And if we compare the building that appears in OpenStreetMap and in OvertureMap is under is an OpenStreetMap building, but all the other ones are more of Microsoft ML buildings. So this is, it gives an idea of how much the data is, but we can also change the information that we want to display. We displayed before the coverage, and now we are talking about the density. Actually, it's the same layer that is displayed, but the information, as you can see on the top right page, is different. And so that gives an idea on the differences between the 2 data sets in this area. And also you have a data frame or a table on the bottom of the page that gather information depending on the category of the buildings. And here it's either the number of buildings or the density of building in the area. So in our case, maybe it would be better for public administration to actually use OvertureMap data, as it really seems to be more complete than OpenStreetMap. So the second demonstration is about transportation roads. And as it was said before, for the moment, it's not really stable and not released under general availability. And so only OpenStreetMap data is integrated into OvertureMap data. But lately, there were an addition of TomTom roads, especially in Saudi Arabia, in Riyadh. Yeah, Riyadh, I think, the capital. And so one can wonder, what can we expect from this addition of roads in this specific area? So we have a lot of criteria that are actually available for the transportation, but here we're only going to focus on this criteria. In English, it's the overlap indicator. And basically, it shows the difference, the spatial differences between the 2 data sets. So here, the roads in green are present in both data sets, and the roads that are not in green are present only in one data set. So if we're going from the tool, so here we still have the buildings, and so we will choose another area, and we'll try to load the road network. Sorry. So it's not a criterion, it's just the original data set on the area. As the area is quite wide, the time to reload every component might take a while. This is why you have to wait before everything is reloaded. But as you will see, it's quite dense, so it's a bit complicated to actually compare the 2 data sets just by looking at the road network, because it really looks similar. So what we can do is actually use the overlap indicators that I mentioned before. And if we load it, so the roads in greens are roads that are present in both data sets, and in red, present only on the, right data set. Sorry, on the data set itself. So as you can see, OpenStreetMap dataset is almost covered only in green, which is kind of logical because normally all the data in OpenStreetMap is used in OvertureMap. But on the other hand, data of OvertureMap is not the same. So we have, for instance, here in this area, we have a lot of roads that are actually not represented at all in the datasets, and you can see it if you look closely at the sources. So I don't think you can actually see, because even I cannot really see what is written on it, but the sources are displayed into a JSON, and it actually comes from TomTom. And this is the case for, I think, almost all the roads in this area, with more than 300 kilometers of roads that were added. So, yep, sorry. And then you also have the data frame that I mentioned before, with the information that are displayed depending on the category of the application. And so if you look at both, sorry. Anyway, what I wanted to say was that the addition of TomTom roads makes the quality assessment and the comparison quite interesting, because we can see that we do have way more roads that are not represented. So, yep, sorry, kind of messy. So the last thing is about POI, especially if you're either planning to make a trip to Hawaii in Honolulu, or if you're, like, for instance, adjust an agency for a trip planning. So which dataset you use if you want to actually plan a trip there. So here too we have criteria that are the number and the density of POI, but also aggregation of POI according to a mesh that gives an idea of how dense the area is in terms of POI. So let's make the demonstration. So once again we can choose the criteria, and you will see that here the layers will be loaded way more faster because the area is not that wide. And so as you can see on the right map, so on Overture map data, it seems to be more dense in the southwest area, but still it is a bit complicated to actually see if it's how much more dense it is. So what we can do is load the grid area that I was talking about before. So if it's white, that means that there is no places in the grid. And if it's then from green to red, it means that it's less or more dense. So the area is represented totally, because it's not possible to put zero opacity on the when there is no element. And then it is possible to actually compare each grid value for each grid. Yeah, sorry. But the only thing that is actually not really that good is the difference between the data frames, because we have more than 1,000 category of buildings in Overture Map Foundation, which is probably because of the data integration process. But still, as it is now, it's not really possible to compare using this data frame. But if we want to look at other places on the maps, such as on the northeast, you can see that it's both area on the southwest were quite represented, but here it's not really represented on OpenStreetMap. So if we look at it closely, we can even switch to the original dataset to actually see which places are represented. And so depending on the dataset you will use, you might consider going more in the north of Honolulu or more in the south of Honolulu, which highlights the differences between the two datasets. So now, maybe you can wonder how this application works. So first we have requirements. So as I said before, it's a Python application. And it relies, of course, on a database to store the data. So it's a Postgres database with a PostGIS extension, and also pgrouting, an extension for routing. Yeah, sorry. And you also have a common data model for each team. That is really important, because this is how you can compare the two data sets, and also a database model that you use in the rest of the application. So how does it work? As you saw, first you have to select an area and a criterion, and then depending on the criterion you choose, the type of layer, so either a point, polygon, or line, will be different. And this type is related to Loanboard, so the Python package that we use to render the map. So then we choose the good type according to classes that were implemented in the application. And then using GeoPandas, the Python package, to query the information and retrieve geospatial information, we can query the database and retrieve it as a geodata frame, so the way to store geo information using GeoPandas. And then we can, from this, construct the layers and then display it on the map using Longboard. And, sorry. And, sorry. And then we have the information as the criterion information, for instance, or the data frame that will be calculated by the application. So if we look more closely to the components, it's the Shiny application, so the Python package to create the website that is used to send a query to the database. Then the layers will be provided and used both by Longboard to create the maps, or by the backend to calculate the indicator values and the data frame that will both be displayed on the dashboard. So to sum up the process, it's an ergonomic application that is quite easy to use. And also, it has been made in order to be easy to customize. So for instance, if you want to add a new theme, such as the address that were mentioned before, or a new criterion, or even new datasets, such as private datasets, all you need is first to have a common model and map the data to this model, and then implement classes according to what was already implemented in the code. So, but with this, you also have the user and developer documentation to help you doing this. So this is one of the advantages of this application. But of course, as every application, it is still possible to improve it. Particularly, it would be a great idea to actually assess the quality of datasets over larger areas, such as country, because for the moment, we only have areas of 10 per 10 kilometers on average. So it would give a better idea of the quality of the dataset if we could actually assess over a country. Also, the performances could be improved, especially for the application, so loading the layers or calculating the different criterions on the backend process. And so as I mentioned before, adding new criteria or new themes would be a really good idea to help using the tool as much as possible. So we hope that you enjoyed this presentation, and that you will use the tool. Sorry, use the tool. Anyway, yes.
すみません、一つ追加させていただきます。このプレゼンに紹介しなかったのはそのデータの処理自体は結構自動化されてて Python スクリプトでバウンディングボックスを指定してでそのスクリプトが OpenStreetMap とOvertureマップそれぞれのデータをダウンロードしてそのインディケーターを計算してその結果をデータベースに逆プロセスがありますね。でそのデータがプロセス準備されたらその Python のダッシュボードシャイニーでそのデータを可視化できるっていうそのジオデータコンペアはその全部ですねプロセス処理するプロセスと可視化するアプリケーションということでオープンソースになったので興味がある方が企業に自由にツールを使ってイシューとかを作ってもらったら大歓迎なのでよろしくお願いします。
はい、ありがとうございました。発表ありがとうございました。時間が、過ぎておりますので質問はちょっと後の方で、していただければと思います。ではありがとうございました。